Good afternoon. We're starting on page 727. This is number 12, letter A. So when we look at this, we see that we have these two different scientific notations. One is to 10 to the 6th, one is 10 to the 5th. The problem is that the 6 is not the same as the 5. So we take the smaller one, which would be the 5, and we have to write 10 to the 6th as a power of 5. So 2.1, and if I move the decimal 6 places, that would become this number, 2,100,000. And I want to write that as a power of 5, so 10 to the power of 5. So I would write something times 10 to the power of 5. And I would look, what would that be? So if I go 5 spots, I'm going to write it as 21 times 10 to the power of 5. Now that is improper, but I'm doing that because when I'm adding, I have to have the same, what we would call denominator, or second piece, the piece after the mantissa. We want this and this to be the same. And this one was smaller, so we're doing it that way. So we'll rewrite the second one like this, and we'll have 3.7 times 10 to the 5th plus 21 times 10 to the 5th. 21 plus 3.7 is 24.7, and the denominator is 10 to the 5th, is 10 to the 5th, or the second piece there. I'm calling it denominator, kind of like a common denominator in a fraction. So my final answer is not this, because my mantissa is too large. To have the proper mantissa, I would have to have 2.47. Well, if I move that one place over, that means I have to add 1 to the 5. So my answer will be 2.47 times 10 to the 6. All right, B. To do B, we have 10 to the 8th and 10 to the 4th. So another way that we can do those, if you were in a different hour, if you want to just multiply them out and then do the math, that's fine. So if you look down here on C, this would be 2,500, 25,000 minus 310. 25,000 minus 310 is 24,690. So if you do just the math and write it out, you have to answer in scientific notation. So then your mantissa, however you want to say it, would be 2.469 times 10, to the 1, 2, 3, 4. So what I needed you to see was you don't just take this 4 and this 2 and subtract them and you get 10 to the 2. So you either can change it to the bases, like we did in A, and I'm going to do the same way in B, or you can do the math and then change it back. But you can't just go, 2.5 minus 3.1 is negative 0.6, and then 4 minus 2 is 10 to the 2. So with subtracting and adding, you either change this second piece to be the same, or you have to do it out. When in doubt, do it out. So B, I have 10 to the 8th and 10 to the 4th, so I want to change 2.9 times 10 to the 8 to a power of 4. So that would be 2,900,000. So 1 and then 7 zeros. Let's see. 3, 4, 5, 6, 7. So 290 million. And I want to write that as a base 4 if I'm just going to be subtracting. If it was already a 4 there, I could just do 2.9 minus 1.4, but I can't. And that's what I'm making you realize when we change this piece. So to write it as a 10 to the power of 4, I would go 4 spots in. So that would be 200, 29000, so 29,000 times 10 to the 4th. So I have 29,000 times 10 to the 4th, and then I'm going to do 29,000 minus 1.4. 29,000 minus 1.4 is 28,998.6 times 10 to the 4th. So I did this number minus the 1.4 and got this. And then my denominator, or the thing after the mantissa, was 10 to the 4th because I had me get a common denominator. So with this one, we have to change it because our mantissa is too large. We would want the decimal to go here. If we put it there, that changes the original decimal by 4 places. So we need to add a 4 to our exponent power for a final answer of 2.89986 times 10 to the 8th. This is for B. C, I did a different way. You're welcome to do the way I just did it here, or change the base. You would have to change this to a 10 to the 2. To change it to a 10 to a 2, you would have 250 times 10 to the 2. And then you would do 250 minus 3.1 and so on. I'll let you try D at home. There's A, B, C. Let's turn the page and look at number 3, A, B, C, and D. All right. On the back, you get to skip 1 on 728, and you get to skip number 2 on 728. So when we look at number 3, power to a power, these are my favorite. We just have to put clothing on everything so that everything has a power. Let's do these. Here we go. 4 times 1 is 4. So I'll have 3. 4 times 1 is 4. Then I'll have 4. I did 4 times 1. 4 times 2, that's 8. 4 times 2 is 8, so I'll have 10 to the 8th. You are not done just because it wants it in scientific notation. 3 to the 4th means 3 times 3 times 3 times 3. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. All right, so 3 times 3 times 3 times 3 was 81 times 10 to the 8th. Well, 81 is too big of a mantissa, so we would change 8.1 or 81 to 8.1. If we do that, we have to add 1 to our 8 here. So it would be 8.1 times 10 to the 9th. Okay, if we do this, power to a power, 3 times 1 is 3, 1.7 to the 3rd, times 5 times 3, 15. Okay, the reason this is not in scientific notation is because the mantissa has an exponent. So do 1.7 times 1.7 times 1.7. Okay, this will be 4.913. So 1.7 cubed is 4.913, and then we write our times 10 to the 15th. And since the mantissa is bigger than 1 and less than 10, that's our final answer. Okay, with this one, you'll do 3 times 1, which is 3. So you'll have 4.5 cubed. I'm just writing it that so I don't have to throw it up to the big exponent. Times 10 to the 9th. So 10 to a little 9 here. 3 times 3 is 9. Make sure you find 4.5 cubed. If that is not a perfect mantissa, change it. 6 times 1 is 6. 6 times 4 is 24. So you would have 1.2 to to the 6th, so 1.2 times 1.2 times 1.2 times 1.2 times 1.2 times 10 to the 24th. I'm just writing it in a little sentence format so I don't have to do the exponent guy. Like this is what I mean, like rewrite it and put it over here. But you write it like that. Make sure you do 1.2 raised to the 6th power, and if whatever you get here is too big, like when we did it up here, if your mantissa is too big, change it and add so that it's written in scientific notation.